Good evening, geometry students. I'm going to do Module 2, Topic 4 this evening, Transformations in a Plane. Our standard for this topic is GR 2.2. We're going to identify transformations that do or do not preserve distance. The objective for this lesson, you guys are going to be able to identify transformations, and you guys are going to be able to represent reflections, translations, and rotations. The essential question for this topic: what are the essential characteristics of a reflection, translation, and rotation? I'm going to start with the bell ringer. I'm going to pause here for 3 seconds, and then I'll continue on and work on the bell ringer on your own, then unpause, and we'll work this one together. Alright, it says find the area and the perimeter of the square to the right. So the first thing I notice is it's a square. It tells us it's a square. And we've discussed in class, we know that a square has 4 sides that are all congruent, and it has 4 right angles. So we're just going to mark those. The way we're going to do the perimeter and the area on this guy here, so we're going to make a triangle. So we're going to go from A, follow that line until it gets to D, which gives us a right angle. We count across here. We go 1, 2, 3, 4, 5. So 5 across, and then 1 up. You notice we have lines here, but every second line is 1. So don't let that fool you. We started at 1, we went to 6. 6 minus 1 is 5. We went up here. So first we're going to have to do our Pythagorean theorem to get our side. So a squared plus b squared equals c squared. This being our c squared. So 1 squared plus 5 squared equals c squared. 1 squared is 1. 5 squared is 25. 1 plus 25 is 26. So we got c squared equals 26. So we're going to take the square root of both of these. So c equals the square root of 26. Square root of 26 is 5.09. So each side is 5.09. So let's just switch colors here. So for our perimeter is 4 times the side, so 4 times 5.09, that is going to make our, well, let's just call this 5.1. We'll just round it up to 5.1. Sorry about that. 5.1. So 4 times 5.1 is 20.4. So our perimeter is 20.4. Now, area. Area is side squared. It's going to be 5.1 squared. Which we go back over here, we end up with, so our area is actually, hold on 1 second. Okay, sorry guys, technical difficulty there. So yes, our area is going to be 5.1 squared, or as it was down here, 5.09. Either way, it'll be, we end up with the area here is going to be that squared, which ends up being 26. We go back to this 26 over there. What kind of threw me off. Okay. Just do that, 5.1. Alright, guided notes. We're on page 19 of our Module 2 packets. We're almost done. We have this topic and one more. So our guided notes. Let me write these in. One second, guys. a little lacking on space here. I apologize. Okay. A transformation is a function that takes points in a plane as inputs and gives other points as outputs. In a transformation, the pre-image is mapped onto the image. A rigid transformation, also called congruence transformation or an isometry, is a transformation that preserves distance and angle measure. Preserves distance. Just going to do this, an angle measure. Okay. 1 second, guys. Going to write in the next one here and highlight a couple of little things here. Okay, so next up we have a reflection. A reflection or flip is a transformation in a line called the line of reflection. Each point of the pre-image and its image are the same distance from the line of reflection. Okay, so over here to the right, we call this orange line our line of reflection. To the left here, this is our pre-image, and then we know it's our pre-image because this is triangle ABC. To the right, we have our image, and we know that it's our image or after the fact because it's A prime, notice A prime, B prime, C prime. Okay, so what we start with is ABC here. What we end up with is A prime, B prime, C prime. Notice that B is the same distance on each side from the line. C is the same distance, A is the same distance. And each point of the pre-image and image is the same distance from the line of reflection. So if this is 1 over, this is 1 over. If this is 4 over, this would be 4. Say this is 8, this would be 8. Same distance, one side to the other. Okay, underneath we have a translation or slide. Is a transformation that moves all the points of the original figure the same distance in the same direction. Okay, so let's just make this here the blue line. This is our pre-image because it's ABC. Our image is over here, A prime, B prime, C prime. Same distance, same direction. See, we just slid over. Just scoot down here. Give me 1 moment. Okay, again, ABC, A prime, B prime, C prime. Pre-image on the left, image on the right. So a rotation or a turn. See how this, let's see, we'll make this one different color, but notice how we turned. See, B's over here, B's there, A's here, so it's like it went here and then moved over. C went from here to there. So rotation or turn is a transformation about a fixed point called the center of rotation through a specific angle and in a specific direction. Each point of the original figure and its image are the same distance from the center. So if C moves over, looks like it's 1, 2, and then it's 2 over here. Flip over to page 20, down a little bit here. We're going to identify the type of rigid transformation shown as a reflection, a translation, or a rotation. So again, if you look back, reflection, we talked about, it just reflects over the X or the Y axis. The translation's a slide, and then the rotation's a turn. Reflection's a flip, translation's a slide, rotation's a turn. So let's get a little fancy with the colors here. We'll just make this guy blue. This guy orange. Second, I'll make this a little more visible for you guys. Okay, so part A, notice slightly higher. I don't think it's supposed to be. If you notice here, we're reflecting across the line here, right from here to here, from here to here. So this would be a translation. Hold on. Yeah, that's why it's not even. So we're sliding over and then up, over and then up, over and then up. So translation, or slide, up here. So we have the X, we have the Y. Notice that we are reflecting, like the pink is the same over here as it is over here. So let's do this one is a reflection, or it's flipped. Okay, and then thirdly here, we have a turn or a rotation. Like that. If this is, say, A, B, C, then we're going to be we're going to be A, B, C, because it's turning this way on us. Okay, translation, reflection, rotation. All right, coordinate rules. Coordinate rules use symbols to describe how the coordinates of the points of the pre-image change to create the coordinates of the corresponding points of the image. Like here, triangle ABC would become triangle A prime, B prime, C prime, just as an example. Let's look at these coordinate rules for reflections a little further down page 20, excuse me. So when we reflect in the x-axis, first remember the x-axis runs horizontally, the y-axis runs vertically. Okay. When we reflect in the x-axis, so this line goes down here. Okay. So our coordinate rule, our x comma y, and that's how we see the points when we read from a problem like, say, down here, that's x comma y. Well, x comma y is x comma negative y when we're reflecting across the x-axis. For reflections in the y-axis, we're going to multiply the x coordinate by -1, so x comma y will be negative x comma y. Here we multiplied the y point by the -1, the y. So multiply y by -1. Here we multiply x by -1. So again, x-axis from up to down, because we're crossing a horizontal line, it's x comma y becomes x comma negative y. When we're crossing the y-axis, so we're moving, in this case, you see this is a, b, no, excuse me, this is a, this is b, that's a prime, b prime, so it's moving that way. So we're moving from right to left. So we go x comma y becomes negative x comma y. Have some practice underneath. Let me straighten my papers. Give me just a moment. Practice. Triangle JKL has coordinates j at 2, negative 8, k at 6, negative 7, and L at 4, negative 2. Determine the coordinates of the vertices of the image after a reflection in the x-axis. Reflections in the x-axis. X comma y becomes x comma negative y. Simple enough. So here's what we're going to do. We're going to go j 2, negative 8, k 6, negative 7, and L 4, negative 2. Okay, so x comma y, that's how it's written, is going to become x comma negative y. So all we're going to do are j prime, k prime, L prime. So x stays the same. So 2 is still 2. The y becomes negative. So if it's negative 8, it's going to be positive 8. Okay, negative 8 becomes positive 8 because we're taking the opposite, or we're multiplying it by negative 1. So k, your 6 stays the same because x stays the same. But crossing the x-axis, we're multiplying our y by negative 1. So negative 1 times negative 7, positive 7. Okay, L, x stays the same. Y changes times negative 1, so negative 2 becomes positive 2. There you go. That's simple. Just a little lower here, we'll talk about some coordinate rules for translations. Just going back up for just a moment, I want to do this and do this, just so we know what we're talking about. So yeah, back down here, coordinate rules for translations. Translate the figure along vector AB. Okay, so a vector tells us A is the x coordinate, tells us how far left or right we're going to go, and then the B is the y, and it's going to tell us how far up or down we're going to go. So it says to translate a point along a vector, add A to the x coordinate and B to the y. So x comma y becomes x plus A comma B, x comma y becomes x plus A comma y plus B. So it's a little too difficult to see this, but it looks like we went, P was at negative 2, 3, and they moved it. It says negative 2, negative 7, and 3 plus 4. So they moved it. The A was negative 7, the B was positive 4. So that's how they moved it. But let's look at this practice just below here. I can show you a little better. So quadrilateral QRST has vertices, and here are our points. Okay, now we're translating this along vector 7.1. So let me just show you how we're going to do this. Your x comma y is going to be, since this is 7, 1, it's going to be x plus 7, y plus 1. Our vector is 7, 1. Our q is negative 8, negative 2, excuse me, negative 2, negative 8, negative 2. R, negative 9, negative 5. S, negative 4, negative 7. And T, negative 4, negative 2. So Q prime, R prime, S prime, T prime. Alright, so x plus 7, so negative 8 plus 7, negative 1. Negative 2 plus 1, negative 1. R, negative 9 plus positive 7 is negative 2. Negative 5 plus positive 1 is negative 4. Write this a little better. It's negative 2 right there. Sorry about that. Negative 4 plus 7 is positive 3. Negative 7 plus 1 is negative 6. And then T, negative 4 plus positive 7, again, is positive 3. Negative 2 plus 1, negative 1. So here we go. All we did was take the X, do what it said, and take the Y, do what it said. There we go. Easy peasy. Okay, let's flip this over. Give me just a moment. Finish up this evening with page 21. Just lower this a little for you. So now we have rules for rotations. Okay. Notice here we go from here to there. There's your P. There's your P prime. 90 degrees, because in this it's a 90-degree counterclockwise rotation. So actually it went there to there, excuse me, about the origin. We multiply the y coordinate by negative 1 and interchange the x and the y. Okay? So here x comma y becomes negative y comma x. So we made the y negative and we flipped them. 180 degree, so we're going from here 2 times, so all the way over here, 180 degrees. You multiply the x and the y coordinates by negative 1. So x comma y becomes negative x comma negative y. So we kept them in the same place, we just made them both the opposite, or multiplied each of them by negative 1. For 270 counterclockwise rotation, we're going to multiply the x coordinate by negative 1 and interchange. So do like we did here, except x comma y becomes y comma negative x. So we flipped them, but the x became negative. Where it was 90 degrees, the y became negative, but we still flipped them. And we'll go over this enough in practice, hopefully that you guys will get a pretty good idea, or not idea, but you'll remember this. It'll practice enough, and it'll become second nature to you. Go down a little bit here. You may also also find the table below helpful to figure out the coordinate rules for rotations. So as I mentioned in class, right and up are positive. So right and up. So up here it's positive A, positive B. Left is negative. So here it's positive A, negative B. Down here, because this is the 180, it's negative A, negative B. So kind of like let me just sneak this here. Notice this was negative A, negative B. This negative X, negative Y, because it's 180. 180 from where we started, we're negative A, negative B. And then 270 from where we started. So 90, 180, 270, we're B, negative A, which is Y, negative X. So this is kind of, you can kind of interchange these two things together. That'll help. Let's move down here. We got one more practice. Yeah, sorry about that. So yeah. Got one more practice, and then we're going to answer the essential question, and we're done for this topic. So, excuse me. There we go. All right. Parallelogram FGHJ has vertices and gives us the coordinates here. What are the coordinates of the vertices of its image after a rotation of 180 about the origin? Okay. So, x comma y. Go up above 180 was negative x comma negative y. So we're going to go over here, f 2 comma 1, G 7 comma 1, H 6 comma negative 3. I'm going to squeeze I down here, J down here. J is 1 comma negative 3 comma negative 3. Okay, make sure we can see that. Okay. A little arrow, 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 arrow. We'll have F prime, G prime, H prime, and J prime. Alright, so we had 2, negative 1. X comma Y becomes negative X comma negative Y. So 2 becomes negative 2. 1 becomes, hopefully you said negative 1. Alright, 7, negative 7. 1, negative 1. H, 6, negative 6. Negative 3 becomes positive 3. Good job. J, 1 is negative 1, and lastly negative 3. Yep, that's right, positive 3. There we go. Alright, essential question we asked at the very beginning. What are the essential characteristics of reflection, translation, and rotation? And basically, all transformations, give me just a minute. Alright, so for all transformations, shape stays the same. So if you're dealing with a triangle, the pre-image, then the image is going to be a triangle. Same thing, parallelogram, circle, whatever. The shape stays the same. The coordinate or the location is what changes. If you have any questions, let me know in class, or you can send me a message in Teams or an email. Email would probably be the best. It's whitlockw@duvalschools.org. Have a good evening. See you guys in class tomorrow.